So starting here with question 6, we are going to look at 3 different methods, algebraic methods, by which we are going to be able to solve systems of equations, 2 equations, 2 unknowns. And the first method that we're going to look at is the graphical approach. And notice here in question 6, we're told in the following exercise, solve the following system of equations by graphing. And we've been given, just as we were with the first video, 2 equations, 2 unknowns. So that's our system. Only this time we don't have any ordered pairs to plug in and test. It's going to be up to us to determine what is the ordered pair that makes this system true, that satisfies this system. And so we are going to graphically discover what that ordered pair might be. Because remember, as you read through 4.1 in the textbook, there are 3 different scenarios that can happen with a system of equations. The first scenario is that you end up with an ordered pair. You actually have a solution to the system. The second scenario is that there is no solution to the system. And then the third scenario is one in which there are an infinite number of solutions. And we always start with graphing as the first algebraic method by which we solve these systems, because it's a nice way to visually see what it means when the solution to a system is an ordered pair. What's it mean when there's one solution? What's it mean when there are no solutions? And what's it mean when there are an infinite number of solutions? And graphing is a good way to visually see that. So let's dive in. I'm going to stop rambling here. Let's dive in. Let's take a look here at equation 1. We have negative x plus y equals 2. And here's the thing. We are going to use the skills that we looked at in chapter 3, namely graphing, in order to individually graph both of these linear equations on the xy coordinate plane here. So we're going to graph the first equation, and then we're going to ignore it. We're going to graph the second equation, and then we're going to analyze. And here's the thing. You can choose to graph each of these linear equations in whatever method you are most comfortable graphing. So what I mean by that is if you like finding the xy intercepts, go for it. If you like creating a t-table, creating a table of values, go for it. If you prefer putting your equation into slope-intercept form, y equals mx plus b, go for it. Whatever method you like to use, I'm going to encourage you to use that method. And I think for at least this first equation, the easiest thing here to do would be to put this equation into slope-intercept form, because all we have to do is just add x to both sides. And of course, when we do that, the x cancels on the left. The only thing remaining now on the left-hand side is that y. So we have y equals positive x plus 2. So we are now in y equals mx plus b. And now that we're in this form, we can clearly see that the slope, m, is positive 1, right? It's the coefficient in front of x. So the slope is 1. And if you prefer, if you like to see the rise over the run part, remember, we can put anything over 1. So we know that our rise is to go up 1 unit. The run is to the right 1 unit. So we know what our slope is. And of course, based on our b value here, we know that the y-intercept for the first equation here is the point 0, comma, and then b is positive 2. So using those 2 pieces of information, we've got everything we need in order to graph the first equation. So remember, we always begin with b. We always start with the y-intercept. So 0, 2, so there's our y-intercept. And from the y-intercept, we're going to go up 1 unit to the right 1 unit. So up 1 over 1. And there is the next point that we're going to plot. And of course, to create a straight line, all we need are 2 points, and we've got our 2 points, so we're going to do our best here to make a nice straight line for us. Maybe not the best, and of course, if you were doing this in class or on a test, you would be using a ruler. I just don't like to put anything on the screen I'm using because I don't want to scratch anything, but I think that'll be okay. That'll do for now, but we'll see. All right, so there's the first equation. I think what I'll do is I'll switch it up, and I'll put the first equation in blue, and then maybe the second equation I'll do in maybe this pink color here. All right, so let's separate the work, and now let's go ahead and start with 2x plus y equals negative 4. And again, brand new equation. So for right now, we're going to ignore the first equation that's already on the grid. We're going to ignore it, and we're just going to focus on this second equation. And again, use whatever method you like in order to graph this. Again, I think the easiest thing here is just to move this 2x over. So if we subtract 2x from both sides, then, of course, 2x minus 2x is gone, leaving us with just a plain old y on the left is equal to now negative 2x minus 4. And now that we're in y equals mx plus b, we can identify those two key pieces of information. We can see that our slope is negative 2, right? The coefficient of x, so negative 2. If you want, of course, just like we did in the first equation, we could very easily put this over 1. Then you can clearly see the rise over the run. In this case, the rise is really a fall, so you're going to go down 2 units and to the right 1 unit. And then based on the value of b here, we know that the y-intercept is going to be the point 0, negative 4, right? The b value here is negative. And using these two pieces of information, again, we've got everything we need in order to graph. So we always begin with the b value, or in other words, we begin with the y-intercept. So starting at the origin, this 0 for x says don't move left or right any, but that negative 4 says go down 4 units. So we plot the 0, negative 4 y-intercept. And then let's see, our slope to get to the next point says go down 2 units and then run to the right 1 unit. So down 2, 1, 2. To the right 1, so there's where the next point lives. And again, we're going to do our best to connect these two with as straight a line as we can manage. All right, so here's the caveat. Here's the little thing that we have to remember with graphing. I told you at the beginning of this video, we're going to look at 3 methods by which we can solve a system of equations. And they are going to be graphing, substitution, and elimination. I think I mentioned that. If not, well, there they are, the 3 methods that we're going to look at here in 4.1. Graphing is the least accurate method by which you can solve a system of equations. And I should say the least accurate method if you're doing it by hand. Because here's the thing. Although these 2 lines are correct, right? We did everything perfectly fine. I did them by hand. And of course, by nature, drawing a graph by hand is probably not the most ideal scenario because we are not perfect, right? Our lines aren't particularly perfect. And so it can be difficult to see, well, what's the ordered pair? Where does it appear these 2 points, or rather these 2 lines intersect each other? Now on the graph that I made here, of course, that point is right here. But that's not a very pretty point, right? Is that ordered pair, negative 3.5? It gets messy. So here's what I would tell you to do. You could either regraph this, or what you could do is after graphing this, if your graph isn't perfect, you could use one of the other methods that we are going to look at, namely substitution or elimination, in order to verify or check. So what I would encourage you to do is, again, on your test, if you're asked to solve a system by graphing, that's the method by which you're definitely going to have to use. But to check yourself, use elimination or substitution. But here's what I'm going to do. Because we haven't looked at either of those methods yet, I'm going to actually see if I can make the graph just a little bit more accurate. And to do that, I'm going to use or plot multiple points using our slope, right? So remember, here was our y-intercept. We went up 1 over 1. Well, we could keep doing that. We could go up 1 over 1, up 1 over 1, up 1 over 1. Or from that y-intercept, we could reverse the process. So instead of going up 1 and to the right 1, we could go down 1 and to the left 1, right? Down 1 to the left 1, down 1 to the left 1, down 1 to the left, down 1 to the left, etc., etc. And here's now what I'm going to do. I'm going to now try to connect these points with, again, as straight a line as possible. And then I'm going to repeat the process with the second equation, and let's see if we can determine the ordered pair. Now again, the y-intercept was 0, negative 4, and our slope said go down 2 over 1, so down 2 over 1. But I'm going to reverse the process. So instead of going down 2 units and to the right 1, I'm going to go up 2 units, 1, 2, to the left 1, up to 1, 2 to the left 1. And I think we just discovered where these two lines are going to intersect, but just 1 or 2 more points. So up 2 to the left 1, up 2 to the left 1, and then I'm going to do my best to connect these. Oh, that was terrible. Connect these with, again, as straight a line as we can muster. Even then, not very, very accurate, perhaps that pink line, but because we plotted multiple points, we can now definitely see where these two linear equations intersect each other. They appear to intersect each other right here at the ordered pair -2, 0. So what we just did is we graphically found the solution to this system of equations. Remember, the solution to a system of equations is the ordered pair that makes both of these two equations true. And now that we've done that, we are claiming that -2, 0 is the solution to the system. What I would recommend you do is take this ordered pair and substitute it into the first equation, make sure you get a true statement, and substitute it into the second equation, make sure you get a true statement. All right, so again, this is the process by which we can solve a system of equations by graphing, but as you can see here, sometimes not very accurate, depending on how good or not so good, in my case, you are at graphing. Now, I'm not going to do that here. I'm going to leave the checking, the algebraic work to you, but we are going to say -2, 0 is our solution to the system. So -2, 0 is the solution to the system. All right, there we have it. Question 6.